Okay, problem 22 in chapter 4 is a basic stoichiometry problem, and I could write out the solution for you and just post it, but I thought some of you might appreciate seeing a little bit of an explanation. So the first thing that we need to do is balance the equation. So you might get started like this. Potassiums to be balanced need a 2 here. Because there's 2 here, carbons are balanced. The oxygens, there are 4, plus 2 is 6, and on this side there are 5. So an odd number of oxygens here and an even number here. The only thing I know to do then is to try something other than a coefficient of 1. So we'll try 2 and basically start over. Potassiums, now there are 4. Carbons, now there are 2 on a side. And oxygens, there are 8 here plus 4 more. That's a total of 12 on the left-hand side, on the reactant side. And I'll need to balance that with 12 on this side. So that means I need a coefficient of 3 here. So I now know the following, and for stoichiometry this is probably the most important thing. 4 moles of KO2 react with every 2 moles of carbon dioxide, always in this ratio, to make 2 moles of potassium carbonate and 3 moles of oxygen. All substances are now related in this 4:2:2:3 ratio. And so as I turn my attention to this particular part, which is actually part B of the question, I can talk about any quantities related as maybe CO2 is related to potassium carbonate, or maybe if I use a certain amount of KO2, how much O2 can be produced. I could answer any question related to these 4 substances because I know how all of them are interrelated. This particular question is about grams of KO2. That's what I'm looking for. And I'm starting with 100 grams of carbon dioxide. So this is really the problem that I'm trying to solve. How much KO2 is involved if there are 100 grams of CO2? All I know is this relationship right here. For every 4 moles of KO2, there would be 2 moles of CO2 involved. So that means I'm going to have to first start my stoichiometry by always getting the most useful unit, and that is moles. So that means I'm going to first convert these grams to moles. The chemical equation is kind of like a standard recipe here, and it always tells me how the mole quantities of each substance are related to each other. It doesn't tell me how grams of KO2 are related to grams of CO2. So my first step is going to be to convert this quantity, this mass, to moles. I'll come back and fill that in just a second, but the reason why I'm going to do that is so that in my next step of the dimensional analysis, I can convert moles of CO2 to moles of something else. In this case, the something else is KO2. That's what I'm trying to find. This information is kind of the key step in all stoichiometry calculations. It allows you to convert from one substance in the equation to another. And the relationship here comes directly from your balanced equation. 4 moles of KO2 are always involved when 2 moles of CO2 react. Once you do that step, we can then convert moles of KO2 to the desired unit of grams. In a laboratory, if we were to really do this reaction, we would measure the substances on scales and we would know their masses. Scales don't read moles, so that's why the mass is the more important one for us to find. Okay, so that's where your balanced equation is critical. You get this type of relationship from it. I'm going to slide this up and we'll go ahead and finish this. In order to complete this, we need to fill in these conversion factors. So we're missing a little bit of information. These numbers here will be ones. And the missing values are called molar mass. So here I need the mass of 1 mole of CO2, and that's 12 plus 16 times 2, that's 44. A mole of carbon dioxide weighs 44 grams. We did that so that we could cancel moles of CO2 and convert to moles of KO2. We use the balanced equation in this step, the coefficients from the balanced equation. And then once we have moles of KO2, we can convert those back to grams of KO2, and we need the molar mass here. Potassium is 39. Each oxygen is 16, so that is a molar mass of about 71. That cancels. So then you just put this in your calculator, 100 times 4 times 71 divided by 44 and divided by 2, and I get about 323 grams of the KO2. And this same problem-solving technique allows you to solve for any substance as long as you know another one in the balanced equation.